Hi everyone, welcome back. We continue on this list and today we are going to learn about power function. This function similar to the power function of C++, standard library of C++. This function also let us to get the power of each pixel inside an image according to the specified power value we are giving as input to this function, and this can be in double values, no need to be integer, and accordingly it will give you the output array which is calculated by each pixel's power value is gonna be inside this output array. Okay, before starting, maybe I need to warn this function is potentially expensive function, we can say computationally expensive function, and before using this you need to think twice because maybe you don't really need this function. Just keep in mind before using this function you need to be careful. And which cases we can use this function? Let's say we can use this for image enhancement. You can use this function to adjust the brightness or contrast of an image by just increasing the pixel values, or you can use for color manipulation. Let's say you can use also to change the color, the RGB values of an image just by increasing each of the channels RGB pixel values, let's say, yeah. So by just to keep, this is a function which is exponentially increasing the pixel values, so the higher values is gonna get the more higher than the smaller one. So in some cases maybe you need this kind of special cases, you can use this function. Okay, this is the previous code from the previous video. We already designed this code, and for this video we don't need this input 2, we only need an input 1 because I want to create my own image, so we can continue on that one and we don't need to input 2, just we need input 1 and input 2. So this function, CV power function, can take any value, can take any image. So for example, in here we have 8-bit single channel image. So if we give this one as input, it's gonna give us the output in the same type of image. So secondly, we need to also, here is the second is the parameter is power value, and the third one is gonna be the output. Let's specify that, and let's start from the 2 simply, and after that we need to specify our output. So the type of the output is gonna be same with the input, and let's see how it looks like. Since we let's see, first of all, you see in here all of the values getting 255 because we specified the input as 8-bit and single channel image, so it's nothing to do, it cannot power of 2 power of this 77 is gonna be a high number than 255, so it cannot reach that number because it's limited with 8-bit, so the maximum value is 255, so that's why it's giving you this number. If you, let's add one more maybe in here, let's say which value we don't have, 0 to 0, let's say, and if this is a small value, let's say 4, and see the result, it's gonna give 16 because it's already has inside 16. Yeah, for that maybe we can change the type so we can see more correctly how it's working. 32 float type and one channel image is enough. So now it's gonna give me all of them, but we cannot see, of course, because the float type image you cannot use with imshow. So let's just comment out them and see via on the console. And here we can first of all input 1, and after that we can write to the console the out, and we will see how it's working. Let's try. Okay, here this is you see in here there is something wrong, I believe. Why is giving me this number for 0 to 0? Because it shouldn't be expected, and the others one also giving me the 0 values. Why it's like that? Okay, let me try to figure it out. Float type, sorry, because we specified the input values as unsigned char, we need to specify as float because our inputs are float. So whatever you're assigning is not recognizing and giving you error. By this we see our fault. Okay, now yeah, in here 4 equals to power of 2 is 1677. If you calculate, it's gonna be equal to this one, and it's continue on that way. So we see it's just 77 times 77, 2 times you are multiplying 77. Yeah, and even you can use, we said, the double values. Even in the computational it says in here something for 0.5 and minus 0.5 is specialized faster algorithms are used to the special case of these values, and we can use it also. Let's say, yeah, and here basically you are just getting the square root of each value, we can say. Yeah, some things let's remember again, then we can finish this video. First of all, you need to be careful before using this function because this is computationally expensive, and you can use this in some cases, of course, but those cases can be just like color manipulation or image enhancement kind of. And also in those cases you need to be careful about the type of the image, because if you give 8-bit image, and if you give the pixel values are like this kind of, it's not meaningful, because it's gonna be more the number of the result is gonna be bigger than 255, 200, bigger than 8-bit values. So it's also should this point also you need to be careful. Yeah, I think I'm done for this video. See you in the next videos.